All right. Thank you very much, Kelly. I am Rolando Delgado, the contact area engineer for this region, and I'll discuss the assembly and installation of our aluminum box covers. Aluminum box covers are lightweight, durable, hydraulically efficient, and cost-effective solutions for very bridges applications. These slides are designed to familiarize our customers with the process of properly assembling and installing aluminum box covers. Our aluminum box covers are custom fabricated at Context Manufacturing Facility in Winchester, Kentucky, from solid aluminum pieces and reinforcing ribs. These parts are all corrugated, pre-punched, and curved prior to delivery. If required, aluminum head walls, wing walls, and inverts are also custom built to the project specifications. Now, I understand some of you might be interested in a plant tour. Please contact your local bridge consultant and they'll be more than happy to help facilitate that tour. At the manufacturing facility, the nested bundles of corrugated plates and ribs are secure onto dunnage for shipping and unloading. The maximum weight per individual lift will not exceed 5,000 pounds. On site, unloading equipment should be suitable for handling the bundles safely without risk of damaging the plates, the ribs, or any of the other components. Fasteners and other hardware are shipped on pallets in pails labeled at the top and the side. Plate layout drawings, assembly instructions, and safety guidelines are shipped with the structure, typically in a pail designated with a different color lid. This pail also contains the bill of material that itemizes all of the plates, ribs, fasteners, and hardware included in the delivery. Please completely check the delivery materials against the bill of materials that was provided and contact the Winchester plant if you have any issues with the shipment inventory. Take time to review the assembly in detail. Those drawings are very important to have in front of you and look at them in detail, compare them against the bill of materials. The plates and the ribs must be oriented as is shown on the drawings. All the plates that are designated with the same letter are identical and interchangeable. The ribs are designated with a CR for crown rib or an HR for haunch rib, and that's going to be their label, and they also have numbers. Identical plates and ribs will be bundled together, but they will not be individually marked with a letter or a rib mark designation. Please keep the plates and ribs of the same type and length together to avoid any confusion. Customer cut plates will be marked individually with a number that corresponds to the assembly drawings. All right, so now we realize that many of you use our on-site plate assembly services on your aluminum box culvert jobs. For you then, the site preparation and backfilling part that are covered later in the presentation will be the critical part of this slideshow that you'll need to pay attention to. However, some of you, from time to time, self-perform when it comes to assembling the aluminum box cover structures. This presentation in its entirety is designed for you by covering site preparation, plate assembly, as well as backfill. To start on the site preparation, you want to make sure that the site is dry and any necessary dewatering or water diversion is taken care of before you start the assembly. It is important that all the bolts are torqued to the design range, and this cannot be accomplished when they are underwater. Even if you build the shell in the dry on top of the road, you still need to bring it into the hole and attach the wing bolts. Therefore, the water elevation still needs to be controlled to allow proper attachment and torquing of the bolts to those wing bolts. The total limits of the excavation should be wide enough to account for the critical backfill envelope of the structure, which may be up to 6 foot wide on each side, as indicated on the plans. Prior to installation, it's important to verify that the bearing capacity of the soil in place is in accordance with the design of the structure. Preparation of the bedding is also critical for a successful installation. The structure should rest on a minimum 5-inch thick layer of loose granular material with a maximum particle size of 1.25 inches. Like I said, for those of you who self-perform the assembly, the next section to be covered will be the assembly of the shell, head walls, and wing walls. All bolts are 3/4 inch diameter for use with an 1.25 inch wrench or socket. You can use the table shown on the plans to determine the proper bolt length for each location based on the plate thickness, the number of overlapping plates, and the type of each rib at that location. Separate the pails of bolts by length so you can avoid any confusion once you're in the site. The appropriate torque range for all the bolts in the shell and invert plates is between 100 and 150 foot-pounds. Insert the bolts from the inside of the structure so the nuts are located on the outside of the shell. Always tighten from the nut and make sure that the spherical rounded end of the nut is positioned inside, facing the plate or the rib. Now with each shipment, Contact provides a rib assembly socket to simplify tightening of the bolts at the rib locations. This socket has a 3/4 inch drive. Contact also provides a step drill bit for field drilling and reaming when required. Now, in addition to the tools that are provided by Contact, it is recommended that the contractor have the following tools on hand during the assembly. A 3/4 inch diameter impact driver is going to be necessary to properly torque the bolts. Corded electric or pneumatic impact drivers are recommended by Contact. All bolts will require an 1.25 inch socket. As spot wrenches, pry bars, 2-pound hammer, those tools are going to help with bolt alignment during the assembly process. Lifting hooks can help with the material handling. A torque wrench should be on hand for verifying the bolt torque. And you may need some scaffolding or ladders to safely access parts of the structure. All the workers should be equipped with OSHA required personal protective equipment. The curved plates will be slippery due to the oil that is used in the manufacturing process. Please take the appropriate precautions when handling or walking on these plates. Gloves should be worn at all times. Never insert finger into bolt holes or between the plates. We also recommend that you wear hearing protection. Now, aluminum box covers accommodate a variety of different foundation systems. These include full aluminum inverts with toe walls, aluminum footing pads, cast-in-place concrete footings, as well as our steel and concrete express foundations for any type of accelerated construction schedules. This tutorial today will focus on structures with full inverts. So let's start. Beginning at the outlet end of the structure, lay out the invert plates as is shown on the assembly drawings. Inverts on longer span structures will have a longitudinal seam. Assemble the seam with the plate standing up before attaching to the next row of invert plates. Make sure the holes for the supplemental plates are positioned towards the outside of the invert. Bolts should be inserted from beneath so that the nut can be tightened from the top of the invert. A board placed under the leading edge can help hold the bolts in place when connected to invert plates. Proceed with invert assembly moving upstream. Just finger tighten the nut onto the bolts at this stage. When all the invert plates are attached, supplemental plates, if required, may be placed as shown on the plans. The bolt holes in supplemental plates will align with the bolt holes in the invert plates. Receiving channels are placed next. These should be oriented so that the taller curved leg is facing the inside of the structure. Insert the bolts from below, propping up the invert as needed. A gap will be present between adjacent sections of receiving channels. Measure to ensure that there's an 18-inch spacing that is always maintained between the end slots of vertical legs. When the receiving channel is in place, all of the invert bolts should be tightened to a minimum 100 foot-pound torques. Next, the assembly of the shell can now begin. Now, for proper plate overlap, begin assembly of the shell at the structure inlet. The first shell ring may be assembled laying on its side. Hunch plates are going to be painted red on one end. This painted red end is placed into the receiving channel. A shorter cut crown plate will be placed at the end of the structure so that you can stagger the circumferential seam. Initially, only place bolts in valley corrugations where ribs are not attached and secure them finger tight. Stand up the first ring and place the painted legs into the receiving channel. Now bolt the haunch plates of the first ring to that receiving channel. Then place the next set of haunch plates over the first ring, followed by the crown plate. Secure the fasteners at the seams finger tight to hold them into place. Now with the second ring in place, you can begin placing the ribs. Attach the haunch ribs at the first circumferential seam. The haunch ribs are also painted red at the ends, that is going to be facing the end ribs. The orientation of the rib is not critical, but should be kept consistent along the length of the structure. Typically, it is easiest to install the haunch ribs by bolting from top or bottom of the rib and working towards the opposite end. Lightly torque the nuts so the plates and ribs can be adjusted until all of the bolts are in place. At this point, you can completely tighten the nut at the seam to their design torque. Now, repeat this process along the length of the structure, attaching new rings and haunch ribs at the circumferential seams only, until all of the haunch and crown rib plates are in place, and the shell is bolted then securely to the receiving tank. When this is complete, all of the crown ribs and any remaining haunch ribs can be installed according to the assembly drawings. Remember, the orientation of the crown ribs should match those on the haunch ribs. If the structure is going to utilize an aluminum headwall or wing wall system, the ribs at each end of the structure must be oriented so that the base of the angle is facing outwards, providing a flat vertical face on the inside for the headwalls to bolt on. When all of the ribs are in place, join together haunch and crown ribs that butt together with a rib splice. Now at this point, go back and ensure that the proper torque has been achieved on all of the bolts. Start with the crown ribs, then move to your haunch ribs, and then the splices. Finally, check any remaining bolts at the plate seams. Show care not to over-tighten the bolts. Scallop plates are installed to help prevent backfill infiltration into the structure. The scallop plates are held in place with scallop plate clips that are furnished with the hardware. Geotextile fabric is also provided by Contact for placement over the shell invert interface. And I'll show you on a slide later on where you can locate that fabric and put it on the structure. A toe wall is typically provided to help prevent undermining of the structure at the inlet and out. The toe wall attaches to the last row of bolt holes on the invert plates. The horizontal leg of the toe wall should be facing outward, allowing access to the bolts from the outside. Bolt the toe wall to the invert plate, inserting the bolts from below and securing with the nuts on top. The trench should be deep enough to accommodate the full depth of the toe wall. Care should be taken to ensure that there are no voids in the backfill behind that toe wall. Any voids should be grouted prior to backfilling the structure. Now, aluminum head walls and wing walls, like I mentioned, are custom fabricated at our facility in Winchester, Kentucky, and is based on the design criteria that's specific to each individual structure. Before you start the assembly of these, take time to review the assembly drawings that are provided for the structure. The plan view is going to show you the location and orientation of the wing walls, the number of anchor rods, and the dead man anchors that are required. The elevation view of our drawings will show you the locations of whale beams, as well as the plate ID numbers that can be used to locate and properly orient the head wall and wing wall panels in the field. The panels will be marked on the sole facing side with a number that corresponds to the assembly drawings. Review the structural details that were provided in the assembly drawings, which show how the wall panels and attachment hardware fit together. Also make sure to review the bill lading provided with the structure to verify that all of the head wall and wing wall panel and hardware were received. If any component is missing, please contact the Winchester plant as soon as possible. Now, aluminum head walls and wing wall assembly begins with a completely assembled and properly torqued aluminum box covered shell. The head walls and wing walls will extend beyond the invert of the structure. You need to trench to provide adequate depth for the walls along the entire length. Please make sure the excavation extends beyond the limits of the wing wall dead man anchors. The dead man anchors are designed to be entirely embedded in structural backfill material. Now begin by attaching the interior center panels to those end ribs. The panels can be bolted together at the vertical seams where they overlap. Center the panels on top of the structure and ensure that they are level before you start bolting them to the end rib. The connection of the head wall panels to the end ribs requires fill drilling through both parts. Contact furnishes, like I mentioned, a step drill bit with the structures for this purpose. Begin at the crown of the structure where the outside crest of the panel makes contact with that rib. Drill a 7/8 diameter hole through the center of the end rib and the wall. Use an 1.5-inch bolt to connect the two pieces. We recommend the use of a non-petroleum-based lubricant when drilling to expedite the process and extend the life of the reamer bit. Now continue to fill, drill, and bolt the end ribs and panels together along that perimeter of that arch. The connections should be spaced at a minimum of every other corrugation. Next, bolt the head wall end panels to the center panels and secure them to the structure in the same way by fill drilling through the end rib. The end panels are going to slide in between the toe wall and the notch cut in the inward plates. Corner panels are connected to the head wall end panels with a 3-piece hinge corner joint. The corner joint consists of open and closed tabs that bolt to the wall panels and a central splice that connects the two together. The open portion should be bolted directly to the end panels using an 1.5-inch bolt. The closed portion is bolted to the wing wall corner panel. Once the head wall panels and corner joists are in place, the head wall cap can now be installed, centered over that head wall. Elbow caps are custom fabricated for each corner joint and slide into the head wall caps. The head wall caps are secured to the wall panels with a 3-bolted connection cluster at the center line of each panel. The holes for these connections are fill drilled through the caps and the wall panel. Let's move to the wing walls. So corner panels are the wing wall panels that are closest to the head. Orient the corner panel to the angle that is shown on the plans and bolt it to the corner joint. Bolt on any additional wing wall panels as required using 1.5-inch bolts at the vertical seams between the panels. Now, you need to brace the walls as required to maintain a vertical orientation and a proper angle with respect to that head wall. Whale beams are used to reinforce wing wall panels and provide a means for attaching the dead man anchors. The assembly drawings will dimension where the whale beams are to be attached to the structure. Holes for the attachment hardware must be fill drilled in the wall panels at the location that is shown on the plans. The shaded circle on the plans is going to indicate holes for anchor rod connections, while the open circles or white circles indicate bolted connections between the whale beams and the wing wall. All whale beam connections are made with threaded whale nuts that slide into the channel formed inside the whale beam. Slide all the whale nuts into their appropriate location before bolting on that whale beam. Use 2-inch bolts to attach the whale beam to the wing wall panels near the ends of each panel. Wing walls are supported by dead man anchors that are embedded in the structural backfill. The dead man anchors will be prefabricated with a reinforcing angle welded to one side and drilled to accept the anchor rod. At the wall panel, anchor rods are secured to the whale nuts that were previously inserted in the whale beam channel. Thread a nut approximately 6 inches onto one end of the anchor rod and insert it through the previously drilled hole in the center of that wing wall panel. Thread the anchor rod into the whale nut and then tighten the nut on the wing wall panel to complete the anchor rod connection to the whale beam. Now on the opposite end, make sure the dead man anchor is oriented such that the reinforcing angle is facing away from the wall panel. Thread a nut about 3 inches onto the anchor rod. Insert the anchor rod through the dead man assembly and thread a second knot onto the anchor rod securing the deckman anchor in its place. The elevation of the wing wall anchor should be set as shown on the assembly drawings. Wing wall caps slide over the wall panels and cover the other end of the elbow cap. Attach the wing wall caps with a 3-bolt connection at the center of each wall panel, similar to what you did on the head wall. The end caps slide into the end of the wing wall caps, and these are not bolted. Now let's go back and work on that head wall, finish that head wall. On standard head walls, a Type 6 rib is provided to secure anchor rods just below that head wall cap. The rib is punched with holes 18 inches on center for bolting directly to the wall panels, and additional holes at the center of each panel for anchor rod connections. We need you to field drill through the head wall panels at the corresponding hole locations. Secure the wall panel connections with 1.5 inches long hole. For anchor rod attachments, thread a nut 6 inches onto one end of the anchor rod and insert it through the center bowl hole. Secure the anchor rod to the rib with a nut on the front face and then tighten the nut on the back side to complete the attachment. Head wall anchor rods are secured to the structure at the rib locations. Extend the head wall anchor perpendicular from the wall and determine which anchor rib is closer to the end of that anchor rod. Field drill a hole through the center of that rib at that location. Use a bolt and a nut to connect the anchor rod attachment plate, or ARAP, to the rib. Use a nut to tighten the threaded anchor rod onto that ARAP so that the anchor rod is straight and has some tension on it. Now, do not over tighten and check to make sure that that head wall remains vertical and you're not pulling on it. Also make sure that the flat face of the ARAP is behind the rib as is shown in these drawings. Now, before placing the backfill, you're going to place a geotextile fabric that is furnished by us over the connection between the aluminum box cover and aluminum head walls to prevent any loss of backfill through those joints. We're also going to place it along the scallop plates connection like I showed you earlier. And now you're ready for backfill. Aggregate products that are free draining and compact well, such as crushed aggregate fines, gravely sand, and coarse sand, make good backfill material for CMP and plate structures. Backfill the structure in accordance with the specifications that are shown on the plans. Structural backfill material may need to be imported if the native material does not have the acceptable properties. Structural backfill material should be approved by the engineer of record. Backfill and bedding material should be a clean, well-graded, granular, free-draining material that meets the requirements of AASHTO M145 for soil classification A1, A24, or A25, or A3, with a maximum particle size of 2 inches. Bedding is also needed in pipe arches and round structures. As per our drawings, the uncompacted shaped bedding blanket should be a minimum width of span over 2 and have a minimum thickness of 6 inches. Now, on pipe arches and rounds, it is very important to fully compact the haunch area of the structure to their required density, as these areas are the ones that push out more on that soil as the load is passing over the structure. The backfill should be placed symmetrically on each side of the structure in 8-inch loose lifts. The backfill should then be carefully compacted around the box. Lightweight equipment should be used to compact the soil to a minimum density of 90% modified Proctor per AASHTO T180. Only lightweight track vehicles, D4 or lighter, should be used for material handling and distribution until the minimum design cover is achieved. Wing walls should be backfilled uniformly with the structures in 8-inch maximum loose lift. The same structural backfill should be used for wing walls and for the shell. Deadman anchors are embedded as the elevation of the backfill increases. Make sure to compact soil thoroughly around the deadman anchors and continuously monitor the wall panels to ensure that they maintain that vertical orientation. Here's a sample of small equipment that you could use to perform these backfill, some backfill. Now, let's talk about loading over the structure. The backfill must be placed and fully compacted to the minimum cover level over the structure before the structure is subjected to any kind of design loads. Keep heavy construction equipment that exceeds legal highway loads off the structure. Light construction equipment on tracks, such as D4 dozer or lighter weight, so about 20,000 pounds or lighter weight, may cross over the structure when a minimum of 12 inches of select material is over the aluminum box cover during the construction process. If construction equipment that exceeds the legal highway loads is being considered to cross over the aluminum box cover, you must call contact and your contact rep to make sure that it is feasible. Now, when you do have multiple barrel installations, the backfill must be balanced across all of the structures at all times. The placement of this backfill may require a backhoe, stone bucket, a conveyor, or some other device to assure that even pressure is felt on both sides of all the structures. You also need to leave adequate room between the structure that is going to be needed to operate equipment for proper compaction. That is all I have for the assembly and installation of these box covers. Thank you for your time.